A very good afternoon, uh, participants and colleagues who have joined us. This seminar is in a hybrid mode, so we have a lot of participants who are joining us online, but those who might be having some connectivity issues might also be watching us on the YouTube. We have today's seminar on a topic which is related to emissions, energy, and climate change, and the focus is on Indian manufacturing. The title of today's presentation is Analysis of the Carbon Emissions, Trends in Indian Manufacturing Sector, Decomposition and Decoupling Approach. This is a paper published by Ms. Himja Sharma and Dr. Balakrishna Padi in Environmental Science and Pollution Research, a very recent issue dated April 23-24 this year. We have this seminar today, and as usual, we will have about 30 minutes for the presentations, which would be followed by 3 discussants. We have lined up discussions by Dr. Vaibhav Chaturvedi, followed by Dr. Santosh Kumar Sahu and Dr. Chandrasekhar Bahinipati. So maybe about 12 to 15 minutes of discussions each is what I think we will follow, try and follow template so that we have about 10 to 15 minutes open for open house discussion. To start, I would just like to introduce very briefly our presenters for today. Dr. Balakrishna Padi is an assistant professor in the Department of Economics and Finance at the Birla Institute of Technology and Science, the BITS Pilani campus. And his co-author, Ms. Himja Sharma, is a PhD scholar in the department. Without further ado, I would invite them to start with their presentation.
So good afternoon, ma'am. Is it audible?
Yes, we can hear you.
So very good afternoon, ma'am. First of all, I'd like to thank ISIT for inviting us to deliver our presentation on this particular topic. And also, I'd like to thanks and good afternoon to all the dignitaries present here, Santosh sir, Bahinipati sir, and from the CS team, CEW team, and everyone. So without further delay, let me share my screen. Okay, so the title of our presentation is about carbon emission trend in the Indian manufacturing sector, a decoupling and decomposition approach. So this work has jointly done by me and Himja. So broadly, this topic is dealt with analyzing the carbon emission trend in the Indian organized manufacturing sector in India. So broadly, if you look, there is a lot of discussion, debate is going on in the recent periods regarding this what should be the optimal emission strategies. And with the industrial development and mitigation emission is one of the most debatable topic in the recent periods. Even the SDG goals discussed a lot on these particular aspects. If you look broadly, environmental degradation and carbon emission is discussed a lot relating about the sustainability path, which involves under the industrialization, and also discuss about generating proper productivity, growth, and as well as jobs in this particular challenge related to environmental sustainability. Even in the recent, this COP28 discusses 2 important aspects. One is called as beginning of the end and the global stock take. So both these aspects discuss about reducing of the fossil fuel, followed by reducing the emission of the CO2 by 2030 to a lower level. It also discusses and encourages regarding global climate finance and green climate fund. Not only that, the IPCC 2018 also discusses how to make a fair balance between economic growth and the environmental sustainability. But if you look in India, in the recent period, there is a rising trend you can find in the CO2 emission, broadly due to this huge demand, rising population, and economic growth. And particularly across different sectors, most of the studies, starting from studies of Bakshi, Kant, and a lot of other studies discusses, and Goldar as well, India is one of the second largest contributor in the carbon dioxide emission in specific to manufacturing sector. And what kind of proper emission policies need to be built to boost the manufacturing sector performance, that is another target. And most of the time the government is recently focusing a lot on that particular aspect. In that particular aspect, when we discuss about the aspect related to growth strategy as well as sustainable emission strategy, so it discusses about that decoupling part. So decoupling is nothing, it discusses the process of growth, how we can able to reduce the CO2 emission. And there's a lot of studies also discusses about how to make environment particularly sustainable and how to can be able to properly examine the linkage between your economic production and reduce the environmental pressure. Not only that, in the recent periods, the environment, the expenditure on the pollution control equipment and aspect of the skills also somewhat leads to this carbon productivity. And in that perspective, studies also highlighted innovation technology, ICT, is going to play a significant role in reducing both energy intensity as well as the carbon emission aspect. Sorry. So in this particular aspect, one of the important theories of the Grossman and Kruger has discussed about the environmental inverted U-shape hypothesis. What is discussed about in the pre-industrial revolution is the relationship between the GDP per capita and environmental degradation. It's going to increase, it's going to reach a particular point, and after it's going to decline. So broadly, what happens when the output rises? The firms offer to cleaner technology and stricter environmental regulations, leading to environmental improvement in the quality as well as the total factor productivity. Recently, a lot of studies also discuss about from this inverted U-shape curve to the N-shaped cruise network approach. And our next aspect is broadly discuss about what is the nexus between your ICT, total factor productivity, and carbon emission intensity. So if you look the ICT is probably about the expenditure, which is given the ASI data, that can have a use effect, which leads to higher energy consumption, it leads to somewhat carbon emission. While ICT also leads to a technological innovation, which can improve the skill and practices. In other words, it can also can reduce the level of production cost. And Indian studies don't discuss about starting from studies of Bakshi, Golder, Mitra, Sarma, Kant, and many other, and the RBI studies also discusses various aspects related to manufacturing, sector growth, and the CO2 emission. But studies in this particular aspect is because of the availability of data set. Most of the studies have analyzed the CO2 emission aspect by following your CMI POS data set. And these studies don't discusses various aspects. One of the aspects discusses how the different type of farm, so the different variations in the emission and corresponding the export intensities. The impact of infrastructure and ICTs, how it is varied among the industries and how it leads to different kind of pollution in the Indian manufacturing sector. The pattern of CO2 emission also follows a non-linear model with the ICT as shows as the transition variable affecting the relations between productivity growth and the CO2 emission. And lastly, it also discusses about improving carbon productivity, which is necessary for a better decoupling studies. So based on this overview, the broader objective of this particular studies, first of all, to examining the decoupling effect between growth and carbon emission, along with its decomposition growth at aggregate level, at the state level in the organized Indian manufacturing sector using ASI unit level dataset. Secondly, it also tried to analyze the nexus between ICT intensity, carbon intensity, total factor productivity in the organized Indian manufacturing sector using the system GMM framework. And broadly, in this study, you have used the dataset, unit-level dataset of ASI from the year 2001 to till 2019-20. And as the recent period also, the 2021-22 is also available. But till we have this did this study till 1920, the dataset was available. So these are simply the number of sampling units and the number of factories specific to manufacturing factories you have considered. And the time period is from 1 to 1920. And as you know, these different data are available in different NIC codes 1998, 2004, and 2008. So you have read the concordance approach, and using the concordance, we have converted all the NIC classification into 2008 classification only for a detailed analysis. Further, following the Golder approach, Professor Golder studies approach, we have divided the 3-digit NIC classification into 3 different groups for doing the decomposition approach, this LMDI decomposition, which broadly follows the level intensity, low capital intensity, and the high capital intensity sectors. And the detailed variables broadly that we have taken in our study includes the total factor productivity, where we have used the basic growth accounting method. And here again, as you know, there are different methods: single deflector, double deflector. You have used the single deflector method. For the capital, you use the fixed capital, and accordingly as a proxy for capital input. And accordingly, all of the variables has been taken to estimation the productivity, and all these variables as given nominal term, you are converted into real term using the particular WPI ZTP deflector, particular WPI deflector in our analysis. Secondly, the information communication and technology intensity has been used in this study broadly about the total, as the no direct information is available. Here you have used the SI factory level expenditure in the IT equipment and divided by total capital input, and that has been taken as a proxy of ICT intensity in our study. The energy intensity broadly is as a fuel consumed per gross value added. Pollution control is available here. Skill intensity, again, there are 2 ways approach has been followed in the studies. One study discusses about the total number of supervisor and managerial staffs. Another approach is about the total number of supervisor and managerial staffs upon total population. That taken as a proxy for skill intensity. Here you have taken this particular, the total persons as working as supervisor, managerial staff as a proxy for skill intensity. And lastly, the carbon emission intensity broadly used here simply by dividing the carbon, the CO2 emission, or ZV, following the earlier studies approach. And the methodology you have applied here includes the Tapia decoupling, log mean divisor index, LMDI, and the system GMM approach. So to begin with, this Tapia decoupling is nothing, is simply a elasticity measure, which broadly reflects the percentage change in CO2 upon the percentage change in ZVA here in this particular study. And this can be divided in 2 parts. One part is about positive decoupling approach, second is about the negative decoupling approach. And this framework has been taken from Baxi and Santosh Avzar's studies. And here the positive decoupling, let's say your CO2 emission is less than 0, this percentage is less than 0, and this GV also less than 0, then it's called as a recessive decoupling. We both are greater than 0, this is called as a weak decoupling. If one is greater than 0, another is less than 0, that is called as strong decoupling, and so on. So this positive negative decoupling has been estimated using this particular percentage sense and according with the elasticity measure approach. Second, the LMDI measure again has been used to broadly find out the drivers of CO2 emission. So this approach again is developed firstly by Kaya. So it is called as a Kaya LMDI measure. So it measures overall CO2 emission by which particular factors. So here you have divided that part into 5 different parts. One is called as output effect, structural effect, emission intensity factor effect, and population effect. So the output effect is about the total changes in the CO2 emission due to changes in output. Second is due to structural industries, and so on. So that can show how the CO2 change can be explained by each of these different factors. Next, we have tried to measure the nexus between total factor productivity, carbon emission intensity, and ICT intensity. So that for that estimating, you have used the 2 different approaches. So first of all, you have taken the CO2 intensity upon this total factor productivity to broadly to measure the EKC hypothesis, whether there is a presence of inverted U or an answered cruise-net curve is present here. So for that, in the first, second, and third model, you have taken again TAP, TAP square, and TAPQ. And to understand the simultaneity, again, you have done some under system GM approach from the carbon emission to the TAP measure, and accordingly, the other particular variables that I have explained earlier has been used in this particular application. So over to Hinja. Thank you.
Thank you, sir. Since we all know that ASI doesn't provide the direct information related to carbon emissions, so following the studies of IPCC 2006 methodology, RBI's working paper in 2022, CCEW 2017, and from studies of Goldar 2017 and Bagchi et al., we tried to estimate the carbon emissions from the data itself. We have not directly completely followed these studies, but we have followed some of the aspects of these studies and tried to find it. Since in the H block, we all know that ASI provides the information related to energy and or the fuel consumed by the firms itself. It is given in the 5 major subheads, that is electricity consumption, coal consumption, petrol and petroleum products, gas consumption, and other consumables are there. Electricity, coal, and gas, all these are given in the quantity. So for them, it is easier to convert them into carbon emissions. But petrol and other consumables are given in the expenditure form, that is in the prices form. So for the next step is to convert these into the quantity terms. First of all, as we know that in Indian manufacturing sector, a wide range of array of petrol and petroleum products are being used by the firms, starting from LPG, natural gas, LDO, aviation turbine fuel, light diesel oil, low sulfur heavy oil. So for the simplicity, we have divided them into 3 subheads: HST, high speed diesel, kerosene, and furnace oil. Later on, we have constructed a fuel price index using the WPI and the data for the prices from the prices of the current fuel prices. And then we have got the quantity by dividing the prices of the to the expenditure and getting the quantity out of it. After getting the quantity, we have computed the CO2 emissions by multiplying that quantity into calorific value and emission factor. So here we have in the study, and we have converted all these 5 subheads into a single unit, that is kilowatt hour, for the further analysis. Next slide, sir. So moving further towards the results and discussion, and from our estimates, we have found there is an increasing trend in the carbon emissions for the Indian manufacturing sector. But in recent year, after 2018-19, we have seen a small dip, and that is due to in the ASI itself, it is given that lesser coal has been consumed in comparison to 2018-19, 1920. A lesser coal is being consumed by the firms. And moving now, we have got the information related to carbon emissions. Now we try to understand the relationship, how the carbon emissions are moving with the output growth. And for the output, we have taken GVA over here. And in the Indian manufacturing sector, we have seen there is a trend of positive weak decoupling is there, and there's no single trend over the period of going on. We have seen a strong decoupling in some years also, and over the time there is weak decoupling. And moving from and comparing the SDG to MDG to SDG transition from 2001 to 2014-5, we have experienced a positive decoupling in the Indian manufacturing sector. And from after 2014-15 to 19-20, we are experiencing END, expansionary negative decoupling. And that is due to in 2019-20, there is a dip in the GVA. GVA has not grown as much in compared to it should have been grown, and carbon emissions have increased in comparison. The rate of change in carbon emission is more than the rate of change in the GVA that has been experienced by this particular sector. So slide change. And further narrowing down the decoupling analysis at state level, majority of states have been showing a weak decoupling, and in some states, West Bengal, Jharkhand, Gujarat, and Odisha, expansionary negative decoupling has been seen. But here the analysis has been done for the aggregate, that means 2001 to 2019-20. And the reason behind could be due to the differential heterogeneous industrial structure, that the industrial concentration is not same in all these states. So we can find the distinct results in all these states. After understanding the after understanding the relationship between carbon emissions and GVA, further narrowing down to the factors that are leading to the or the drivers of the carbon emissions in our study. So here LMDI decomposition of carbon emission is done at aggregate level for the states, and for the whole sector itself. And these are, and there are 4 spells also in which we have tried to find the drivers of the carbon emissions. Here from the graph and the table itself, we can find that output and population are the major contributors of the CO2 emissions. That over the period of time, as the output is increasing for this particular sector, carbon emission is also increasing. But energy intensity seem to lower the carbon emission. It is not that intensifying factor that is leading to the carbon emission in this sector. So next slide. So further moving to understanding the nexus between ICT, TFP and carbon emission intensity, we have employed system GMM. First of all, we tried to understand what is the impact of TFP on CI, carbon emission intensity, along with ICT, energy intensity, skill, and pollution control expenditure. We have seen that increase in ICT has led to the carbon emission. Now, this is distinct from the earlier studies, but the reason behind could be because here for the ICT, we are taking the proxy, that is expenditure on the computer and IT products. And all these installation of all these products and usage of all these products require energy to be used in their operations. So that may be that can be a reason for the increase in the carbon emission intensity due to ICT. Improvement in skill has led to the decline. From our study, we can find that improvement in the skill has led to the decline in the carbon emission intensity. As with better skill, TFP can be improved, which can lead to the reduction in the emissions. Pollution control expenditure significantly leads to decline in the carbon emissions also. And over the for the whole study, we have found there is an inverted N-shaped Kuznets curve is observed from our study, that initially as the TFP will grow, carbon emissions intensity will decline. Then for some time it will increase, and in the long run, it is expected that with improvement in the total factor productivity of the sector, carbon emission intensity will decline for the sector. This means that over the time, the industries or firms will shift to the better and cleaner production processes, which can help to decline the emission intensity of the sector. Since there exists a simultaneity between that, TFP can also, the carbon emissions can also impact the TFP. So further understanding here, we have found that ICT, that carbon emission intensity negatively impacts the TFP, and more investment in ICT definitely leads to the improvement in the TFP, further strengthening the previous finding of some of the studies of Goldar. And then skill and interaction of skill with the ICT can also be seen as positively affecting the TFP, as with better skills, they can use the computer and other softwares better, and it can definitely enhance the productivity of the sector. Increase in the pollution control expenditure also leads to increase in the TFP, as we can see that with the more investment in the pollution control, the carbon emission intensity will decline, and this will lead to the better productivity in the sector. So next. So from our study, the major concern or the major aim of our study was to understand how the productivity of the sector can be improved, and how while mitigating the environmental degradation for the Indian manufacturing sector. And from the understanding the relationship between carbon emissions and the gross value added by the sector, we have seen that there is a weak decoupling over the period of time. That means that though output and emissions, the increase in both output and emissions are increasing over the period of time, though increase in the output is more than the increase in the emissions, but still there is a long way to go where the rate of change in the emissions should be negative, so that we can enter into the strong decoupling zone. And here, for the understanding the drivers of the carbon emissions, output and the population is the major driver of the carbon emission in the sector. And understanding the relationship, how to improve that carbon emission intensity, then more productivity should be there. If there is more productivity, then carbon emission intensity will also decline. And also the investment for the firms should more invest in the pollution control and all those apparatuses, which can definitely lead to the decline in the carbon emission for the particular sector. And understanding the ICT with the TFP, ICT and skill, definitely with more investment in ICT and more employment of the managerial and supervisory staff, total factor productivity of these firms will definitely improve, and productivity will increase with better and digitalized practices and with the appropriate skills. And thank you. Over to you, sir. Sir?
Thank you, Hamza. So, sir, this is one of the attempt to estimate, because there is a non-availability of the CO2 data sets. It's an attempt to estimate the CO2 emission from the Indian manufacturing sector. Again, we have also tried to analyze this thing, CO2 emission by different subsectors within the manufacturing sector. And according to try to show the different kind of patterns and trends here in this particular sector following this organized manufacturing sector in India, and what kind of policy need to be implemented, incorporated. So that is another kind of challenge that we try to highlight it in our particular study. So thank you for giving this opportunity to present our study, and everyone, all the dignitaries here to listen to our presentation. Thank you all.
Thank you so much to both the co-authors for a wonderful presentation, and also for staying well within time. So if I were just to sum up the presentation, the authors have noted that there is a decoupling between emissions and the output, although it is weak, and it shows that we need to continue our improvements in energy intensity, technology, and other things continuously. We need to work harder. What they've also been able to highlight is that it is important to keep going, keep improving total factor productivity. Skills would be important. Implementation of technology would also be important if we were to continue this path of decoupling to lower our emissions as we continue to expand our output in the industry as well. With that, I would quickly like to turn to our first discussant, which happens to be Dr. Vaibhav Chaturvedi. He's a senior fellow and at the Council on Energy, Environment and Water, where he leads the low carbon economy and carbon markets research. I welcome you, Dr. Vaibhav.
Great. Thank you, Dr. Tandon, and very good afternoon to all. And thank you for the presenters. Very, very interesting presentation. And a lot of analytical work, regression-based statistical works, which is always very, very interesting and impactful. So I come from a think tank. So what we have to do is going beyond the research and academic output to also look at the policy implications of those much more kind of carefully. So that is what I'm trying to better understand, because this is very heavy in 15 minutes. I mean, it's very heavy to unpack all the statistics and everything. But what we can definitely do is discuss some, policy implications. So if we can just share the last slide on conclusions, and just look at the implications one by one, that would be very, very helpful. Yeah. See, the first thing is very, very clear. It simply says that ICT positively affects TFP. I think that is also a general conclusion. A lot of studies are supported. Essentially, you invest in IT and your productivity improves. So in that sense, it's kind of a conclusion already there by many studies. The second one is kind of intriguing also, but the way it is framed, it appears that carbon emissions lead to decline in TFP. Like as the intensity of carbon emission increases, TFP declines. So I just want to ensure I'm reading it rightly. Is there a causality here? Which way is the causality? So could you just clarify, Professor Balakrishnan?
So broadly, we would like to examine the causality between this TFP as well as the CO2 emission. So because the higher CO2 emission may reduce the your TFP productivity. That is broadly here, sir.
Yeah, which is a bit odd, because emissions are like the output of everything. Emissions are like effect. It's very, very clear in the literature. Like if you look at the equation also, the way emissions are estimated is they are effect of everything. Like let's say if you completely ignore the CO2 factor of any fuel, then it is just energy consumption. CO2 factors are just like, yeah, you multiply by the carbon coefficient depending on the fuel. So I'm just trying to better understand, can we say that any change in emission intensity in whichever direction leads to anything? I'm not too sure about it. I hope I'm able to communicate clearly what I mean by this. The causality always in one direction of CO2, right? The energy intensity or TFP improves, either CO2 will increase or decline, whatever it is. But the direction is always, CO2 is always the effect. It can never be the cause unless we are talking about climate impact. That's a very different thing. So CO2 emissions lead to climate impact. That is where the causality and direction is, which is very clear.
So actually here, sorry to interrupt, sir. Here.
Yeah.
So actually, you try to address both the aspects. So you have shown the simultaneous from TFP to CO2 and CO2 to TFP. So both ways like already measured and shown here. You can also find from our let's say estimates as well.
Sure. But I'm simply saying that CO2 TFP probably does not mean much. I don't know what it means in reality, CO2 to TFP, right? So, but anyway, I'm just keeping a point for the authors to reflect upon that what does CO2 to TFP change in any way actually mean anything. So that's one interesting thing. A third one is again TFP to carbon intensity, which makes sense. Any change in productivity leads to some impact on carbon emissions, whichever direction it is. But it is that causality is kind of very clear here. In terms of policy implications, what are the big kind of policy implications if you could summarize? Let's say if there's a Ministry of Manufacturing and we have to give some recommendations. So are certain recommendations coming out here very clearly to your mind?
Okay, so thank you, sir. Because this is a broadly we have measured at the aggregate level, and second part also try to measure at a different sectoral level as well. So as a particular aspect, as you know, recently there is everyone discussing about the green jobs as well as a green investment, green climate finance, green funds, which can also leads to overall productivity as well. So what kind of things you can able to ensure? And if you divide, let's say, the total manufacturing into low capital intensive or the high capital intensive or the labor intensive, you can find it's the labor intensive is broadly used the high, let's say, coal. So in that case, there is a differential or heterogeneity also present here. So what different kind of industries need different kind of policies in that aspect. If Hinja, you would like to highlight anything?
Sorry to interrupt you, sir. I would like to highlight one more point. The major aim of one of the major variable for our study was pollution control expenditure, because firms are actually telling us what is the expenditure or expense they are putting into apparatus that lead to the decline in that is combating the pollution that they are going. So our highlight from the study or our policy suggestion from our study would be like the government can intervene, or that can be made for the firms to invest in such apparatuses for sure, which can lead to the decline in the carbon emission for the sector. Because at the end, as you said, only the CO2 is a cause of anything. So that cost should be reduced, and pollution control apparatuses can be one of the way to combat those emissions.
Thank you. I also want to clarify that because pollution control equipment is about local pollution. Carbon emission is a very different variable altogether. So it's like if you use 10 tons of coal, and whether you use pollution control equipment or not, carbon emissions are going to be same. What is going to change is the local pollution, like air pollution, PM 2.5 sulfur. So pollution control equipment is all about local pollution, whichever ones which are listed. So if the underlying energy or fuel consumed is the same in both the scenarios, then carbon emissions are going to be exactly the same. So I wanted to better understand how are you visualizing that link, because that link probably with local pollution equipment is actually not there in reality. And the second thing, you also concluded that it has some impact on TFP. So I was just trying to get the intuition better. Why would a local pollution equipment lead to increase in TFP, like factor productivity? What is really the intuition or causality there, if you have thought about it? So these 2 points, if you could quickly respond. Thank you.
Oh, so the channel we have thought for our study was to go via pollution control, leading impact to the carbon emission, because carbon emission here we are getting it from the energy consumed. So
Yes.
itself is like these are the energy consumed or based carbon emissions, not directly. So it is like a proxy way of going through it.
Yeah,
So
but
we were
pollution, sorry to interrupt, pollution control will not change the energy. That's, I think, the larger point. Energy efficiency will change energy consumption. So that's why energy efficiency and carbon emissions have a close linkage, because it reduces energy consumption, so which is very clear. But pollution control will actually not change the energy consumed. It will change the pollution, local pollution. So that link, I mean, it's fine, the regression, because we have variables. It will give you some statistical parameter, response parameter, which is all fine. But does it really mean anything? That's the larger question. Right? Is there link there in reality? Probably there is no link between local pollution and equipment and carbon emissions, right? Yeah.
Thanks, sir. Actually, here also you have taken the other variable that you can see here regarding the skill intensity. So that is another way to highlight it also for able to increase the skill intensity aspect.
Okay, okay. Maybe I'll stop here and we'll come back. Thank you.
Thank you, sir, for your suggestions.
Thank you, Dr. Chaturvedi, for your useful interventions and very helpful. I'm sure the authors found it beneficial. I just want to add a small query to what Dr. Chaturvedi was trying to ask. So, in terms of your decoupling observations, which was weak, maybe it helps to find out some policies more specifically. Did you find a difference in behavior across labor intensive, high capital intensive, and low capital intensive, so that one can bring out, some non-trivial observations in by comparison between the three categories? Was there a difference? Will that help you to talk what probably Dr. Chaturvedi was prompting in terms of policies? What specific things can be brought out from such rich empirical work?
Yes, ma'am. Actually, here we also done because paucity of time we are unable to show the details. So you take from the labor intensive, low capital intensive, and as well as high capital intensive in manufacturing industries. So we have also saw the decoupling in different aspects. Number one. Second is about when the government implements different policies. Let's say we have tried to measure before SD, like from transitioning from MDG to SDGs. That is 2001 to 2015 and 2015. Also, and certain policies also government has implemented. Before that and after that, what kind of changes, whether the decoupling has what kind of weak decoupling, there is a strong decoupling. We also have measured that. If you want, we can also show you the estimates. Thank you, ma'am, and for your valuable observations.
Okay. So do you have any more interventions? Okay. So thank you so much for your responses. And I would quickly turn to our next discussant, which happens to be Dr. Santosh Kumar Sahu. I'm sure he's online. We saw him online when we started. Yes, I can see him on the video. Hi, Santosh. How are you doing?
Yes, I'm good. Thank you. Thank you very much.
Good to see you. So just a line of introduction before I hand over to you. Dr. Santosh Kumar Sahu is an associate professor at the Institute of Technology, IIT Madras. His research interests happen to be in energy economics, industrial economics, and economics of global climate change. With that, I invite you to make your discussion and comments on the author's presentation.
Yeah, thank you. Thank you very much for the invite. I must thank Prosubina who get in touch and invited me for this talk. First, I would congratulate the authors to publish this paper in Environment Science and Pollution Research, a competitive journal to accept papers from multidisciplinary approach in economic studies. My comments are largely, because the paper is already published, my comments are largely how we can relook at the paper for different ways that we can enhance the paper for better audience and better outcomes. For instance, if we can go to the slide number, I don't remember the slide number, the graph where the decomposition is shown, the state level decomposition is shown. Some interesting evidence comes out there. For instance, Gujarat, Kerala, Maharashtra, and Odisha, these are the 4 states where the data comes from. They have negative emission factor. So it is interesting. Maybe the other one, which is the other graph, which is a bar diagram, I guess, histogram kind of a thing, if I remember correctly. Yes, this one. So if you look at it, Gujarat, Kerala, Maharashtra, Odisha have a negative CO emission factor, which is below 0, which means probably they're efficient in terms of comparatively emitting less. And it would be interesting to look at this cluster of the states, why it is happening, what kind of factories are there given by ASI, what kind of product they come up with. Is there a difference in product mix, stuff like that, which will actually enhance the understanding on carbon emissions? Because as clearly pointed out, the estimation of carbon emission is done using a bottom-up approach, using the energy consumption into picture. It is not the top-down approach where you get the data and then do the analysis. So therefore, understanding the state and answering why negative emission factor is come up with these 4 states would be highly important particularly to come up with state level, policies on sustainability, emissions, and other things. Similarly, if you can look at other states like Chhattisgarh, Andhra Pradesh, Himachal Pradesh, Karnataka, Rajasthan, Tamil Nadu, and Uttaranchal, they have negative energy intensity, which essentially indicates that is there a possibility that they have attained energy efficiency. And because this is unit level data, it is also interesting to see that in which way they have kind of got these negative values, because it is definitely either because of increasing energy efficiency or maybe reducing output, because the definition is energy divided by output, and the emission definition is again CO2 emission divided by gross value added. So these two parameters are price sensitive. So the question would be, is there a differential price mechanism for energy sources that leads to this kind of grouping of states for similar indicators? Like for emission factor, there are states which are negative. For energy intensity gain, there are similar states. But if you carefully look at Odisha, for instance, it's a state with mineral-based states, but Kerala may not be using that much of industrial activities, but still they have similarity in terms of negative emission factors. So this initiates to think about, can we rethink about the paper again for another approach where we explain these diversities along with the econometric exercise being done. I congratulate for all the econometric exercise being done in the paper, but at the same time, this gives us a little bit more flexibility in understanding the data better. So if the authors can put some highlight on this issue first, then I would have my other comments once I receive some comments from them.
Thank you, sir, for your valuable suggestions and quick comments. So broadly, your papers also helped us a lot while, let's say, framing this particular study. So thank you. So yes, actually, you will find a lot of heterogeneity across states. Analyzing broadly as you can find the emission factor aspect as well as the decoupling aspect. And sir, again, when you try to measure, let's say from 2001 to 2015, let's say from the MDG period that I have discussed right now, and from 2015 onwards, so you can find there is a lot of changing positioning of the states. So this is broadly for the aggregate level. But if you're going to situate this thing at a different point of time, so different kind of trends are also, so you can find. So as you rightly pointed out, so different states need different kind of energy, different kind of policies for reducing this particular emission factor. And as you can rightly highlighted, let's say some few states here, which directly reflect, let's say, expensive and negative decoupling, broadly West Bengal, Jharkhand, Odisha, and Gujarat, that you rightly highlighted here. So different kind of policies also measures as needed. So for that, sir, actually, again, try to look out, looking in another aspect, across different sector-wise as well as state-wise. So that is the ongoing work that we are currently doing, sir.
Yeah, thank you. Yeah.
Sorry to interrupt.
Yeah, please go ahead. Yeah.
So the thing is this, we have divided the industries into 3 basic categories for the analysis, not the initially the 14-digit classification is given. What we are trying to further do for the study is that to understand that if those 69 industries are there and which are more polluting in nature, and we have to understand how those 3-digit industries, 69 industries, how they are located in these states. And actually, then only we can get a better picture of the energy intensity, that whether those industries are consuming that much fuel or not. Because that is the issue. Because here we have just aggregated all those 69 industries and we are just getting a broader picture of 2001 to 2019-20. But the years are being changing, and 19-20 is a hit period for that. Because last quarter is a quite hit period. So we cannot be directly be conclusive. For the further analysis of the study, we are in the progress of that.
Wonderful. Thank you. The next one is, see, you have also used electricity consumption as one of the energy sources where you have arrived at the CO2 equivalent, right? So a little bit of caution here, because electricity is again, is not direct fuel. It's basically created out of some kind of a fuel. For example, thermal conversion, it becomes electricity, right? So therefore, a little bit of caution is required when we take electricity approximate to the CO2 emissions, because we really do not know whether they are thermal power plant, they are diesel-based motors, or what kind of source is used to generate electricity for further consumption. So therefore, a little bit of focus needs to understand the nature of electricity, because it's not comparable like coal, right? So it's a little tricky. So I would request to look at this electricity. Of course, there is an emission factor given, But then there are assumptions, scientific assumptions behind this emission factor for electricity. So, for the future work, it is very important if you can look at the electricity and see the results, whether they hold true in presence of electricity, in absence of electricity, because we do not know the source of electricity generation. And the data is not there. I completely agree. The data is not there. It's a very tough job to do it. But the science part of it is electricity has to be understood a little differently than the way we understand kerosene or furnace oil or even LPG for that matter. Right.
So,
Yeah,
definitely
please.
you are quite correct that electricity is a major challenge in most of the studies. If I look into CMIA studies which are being done by you and other people, mostly majority by yourself, that electricity is not being taken. But when we are looking into ASI studies, basically of Goldar's paper and also the recent working paper of Reserve Bank of India in 2022. So there we have seen in the studies when they are conducting for ASI data, since the source of electricity is not clearly mentioned over here, that whether they are whether it can be also a limitation of the study, because if they are fueling the coal and getting electricity out of it, if they are fueling the petroleum or any product and then getting electricity, that there may be a case that they are counting it double also. So that is a limitation of our study, which we have rightly mentioned over there, that we don't know the source of the electricity from where it is coming. But
Yes.
we cannot leave the electricity, because it is hard to leave the electricity as such from the study itself. So that's why we have included it. And definitely when we are not taking the electricity, then there is a difference. Definitely there will be a difference for that. So it can be limitation of the study or can be addition. It can go either way for our study.
Yeah, maybe, because it should not end up with double counting. And also one most important thing is, see, when we calculate the CO2 emission from the energy consumption, we are assuming that the technology of production remains almost same for all factories.
Yes.
That is the biggest assumption that we take, because we are not accounting for the technological change in the production technology or the manufacturing units. So that part we are not taking. Therefore, that idea should come that this is basically the minimum emission that can be done from the energy consumption pattern. Now, one more small request, if it is possible to extend the study, because you have also identified diesel as one of the major source of energy. See, if you read the energy economics from the diesel point of view, the diesel, when it is consumed, it creates two different types of emission. One is a carbon dioxide equivalent, and it creates also nitrous oxide. So it's not only carbon dioxide oxide. Okay, so many of the studies till today are looking at CO2 emissions equivalent. But from this same data set, we can also calculate the nitrous oxide, right? So nitrous oxide studies has been very limited. Even if India, if you look at MSME sector, small firms, small factories still use diesel as one of the source of energy, where we can probably get some kind of a value for the nitrous oxide, which is almost 0.04 kg CO2 equivalent in terms of the emission factor that comes. So that can enhance a little bit more dynamics into the the next paper that you may think of, because a majority of studies has been looking in and around CO2 emissions and CO2 equivalent emissions, right? So that is a suggestion if you could take up. And one more thing, solar energy, of course, we do not know the emissions, because solar energy after installation doesn't have an emission. But see, for example, it acts like electricity, right? So solar cells are produced, then when installed do not have emissions. So a small caution would be interesting to know that yes, this we are not accounting for it. Given it's a renewable energy in the bracket of sustainability studies, we are not accounting for it. Then that makes things little clear for listeners who probably are new to the idea of energy economics or emission economics when you talk about. So thank you very much. These are the comments that I had on the papers, and I hope they are useful. And thank you very much for giving me the opportunity here to speak.
Thank
Over
you,
to
sir.
you.
So, over to you, sir. Sorry to interrupt.
Yeah, please.
But, related to your third theory, so actually, obviously, thank you for the suggestions. We like to incorporate that part in our next study, not only in estimating the CO2, but also estimating the second part that you have rightly highlighted about nitrogen or other aspect. So, including that, so we also try to highlight, like say, across states, which kind of, let's say, measures, so let's say particular factory is there, which may use different kind of, let's say fuel, which is going to be your maybe coal, maybe electricity, maybe diesel. So what is the share of each of this part across states? So that aspect also you are estimating that, and you like to use that in our next study. So thank you, sir, again for your valuable suggestions.
Wonderful. Yeah, thank you. Thank you very much.
Thank you, Dr. Sahu, for your discussion points. I would now request our last and third discussant for the day to make his comments. We have with us Dr. Chandrasekhar Bahinipati, who's presently working as an assistant professor in economics in the Department of Humanities and Social Sciences at the IIT Tirupati. I welcome you.
Okay, thank you. Good afternoon to everyone. Am I audible?
Yes, we can hear you
Yes, yes.
clearly.
Okay, thanks to Beena for the invitation and congratulate both the authors to publish the paper. So any of my previous speakers made my life easy as they talk more about the methodology. Let me go a little bit about the policy angle. Okay, so when you do that, so basically when you talk about sometimes like positive and negative decoupling. Because if you look at that table, some years it is positive, some years it's negative, again it's positive. But actually, what is the reason behind that? Okay, some years that's a positive and suddenly next year it's a negative. Okay, it's not a continuously negative or continuously positive. Okay, and then we you have shown that okay, something around 2000, some years it was a negative and then become a positive. Okay, and basically what policy measures to drive that? Okay, so rather than just talking about that, okay, these things are happening, but did you link that to like policy that was basically framed in last 20 years with respect to the energy? Okay, and with respect to the different kinds of pollution control or the carbon tax, whatever the other things are there. So you should have linked to that. And second thing, let me take an example, because when you consider the CO2 emission, you basically use the different kinds of fuels. Okay, the electricity, coal, and other kind of things basically calculate the CO2 emission. Okay, so did you consider the input, because the purchase the materials and inputs? See, in Odisha, I guess your energy emission intensity, something like a negative, Santosh was mentioning. Okay, but did you look at that? Okay, what kind of farms are there in all the states, in different states? Okay, whether there are high energy high energy emission intensity farms, and things that, see, if you look at Odisha, gross value added output will be less in total, but emission will be higher. Because most of the natural resources are drawn from Odisha and Chhattisgarh has gone to somewhere else for the gross value added. Okay, and so farms are less. Okay, you see that, okay, gross value added is less. Okay, so when you consider, suppose in Maharashtra, okay, and you are taking the resources from Odisha and using that. Okay, because did you consider the like inputs, whether these inputs has any CO2 linkages? Okay, then the basically the CO2 emission level you have calculated, then it will again further increase. Okay, so that's basically how, it's because someone has mentioned that in case of Odisha, the emission is much higher. Okay, the per capita emission is much higher, and actually gross value added is output is less, but actually we are not using that much amount of output. Okay, it's because of we are basically supplying to somewhere else. Okay, they are basically producing it. Okay, this is the second thing I just want to point out, and the third thing I just want to link to that to net zero transition, which basically we're talking about. Okay, so can I just in a future paper, okay, so looking at the trend you have, okay, can I just link that? Okay, it would be better to link that. Okay, what this, because you're talking about the now there's one point I mentioned the green jobs, green investments, everything. Okay, so one thing that transition. Okay, so what will happen to the effect of the different sectors? Okay, because suppose you tell, okay, net zero transition, they should move to the basically renewable sources. Okay, so there will be effect on the jobs or whether you have that much amount of skill levels for the green jobs. Okay, so why to link that with the net zero transition? Okay, see that what kind of policy suggestions you can give with respect to different farms. Okay, so that will have some advantage. Okay, yes, now the present study has the advantage we're talking about mostly about that. Okay, what happens? Okay, in the last 20 years or 30 years, what happens and where they are. Okay, but with respect to the future perspective, okay, suppose you tell that policy suggestion, what could be done. Okay, that's I think it's missing. Maybe you can take it. And another thing I think linking to the Dr. Chaturvedi was talking about, when the total factor productivity improves, a CO2 emission intensity declines. Is it true?
Sorry, sir, do you need to answer now or shall
No, I
explain?
just want to clarify when the total factor productivity increases, CO2 emission intensity declines. Because the last slide.
Yeah.
But what is the pattern? Because it declines, then it's again increases.
Yes. So what you got here is an N-shaped kind of pattern, not a inverted U-shape. That is broadly exit studies discuss about the inverted U-shaped Kuznets curve. So what you got a N-shaped kind of thing when you have measured by taking, let's say, TFP, then TFP square, then the TFP-Q. So that you broadly you find here. But this thing again, as you rightly mentioned, you are done at the aggregate level. But if you do the analysis, let's say at the subaggregate level, let's assume labor intensive farms or the capital intensive farms, the pattern may be different. Again, different kind of within different kind of sectors. If again you would like to highlight that part, again we may get some different kind of stories in different kind of sectors. We'll agree with you on that.
But suppose I go by the N shape, but it also increases at one point of the time. Again, it declines, then increases. Okay, but why it increases?
So actually, we try to measure those aspects in our subsequent studies, sir, in detail, in great detail, because this is the first aspect. We like to evaluate different kind of pattern, because as you know, there are less number of studies as done extensive way related to ASI using the ASI data. So this is an attempt to do a detailed analysis on that first part, and the subsequent studies again we like to measure again the green TFP aspects also in our subsequent studies.
Okay, thank you.
And so to answer your first query relating to this, why there is a different years you can find different kind of pattern, this may be state-wise presence heterogeneity, because there's a lot of heterogeneity also present across different states in terms of CO2 emission pattern. That may be due to the changes in that over the point of time. You may expect it to get different kind of pattern, somewhere sometimes a positive decoupling, somewhere is a negative decoupling. So our studies also follows the earlier studies. They also shown by using this data set from CMI, a different kind of over the years. They also got the different kind of pattern related to CO2 emission. So different states, again, as you rightly mentioned, different farms may use different kind of technologies, and different states also follow different kind of transitions. Let's say, as you talk about the import and export aspect, so that part you have not detail highlighted in our study. Obviously, we'll take that your comment into account in our future studies. As you mentioned, let's say somebody's, let's say, about ASI data is get mostly the export data. But again, we try to highlight that aspect in our future studies. Himja, any comments?
No addition to this.
All right. So thank you so much for your discussion comments, Dr. Bahinipati, and I'm sure the authors found all the three discussion points from our discussions today very helpful and useful for their future expansions of their work. If I can now open the floor, if there are any questions from people who are available here, or we could also refer to the chat box if somebody could just open that up. We'll just check if there are any queries or any hands there. Mm. Mm. So I can see something coming from Professor Somesh Mathur. The paper is rich in working out carbon emissions sector-wise. Can you please highlight the formulae GTAP-E does through the formulae? It is at the country level. What about the carbon taxation? I'll read out the next as well so that if you think Dr. Padi and Ms. Himja, if you can, you wish to
Yes, ma'am.
respond.
So as got it as per the comments of Professor Somesh Mathur. So yes, ma'am. Again, in our subsequent studies, actually, we will like to also measure this green TAP aspect. So broadly, earlier studies as discussed when they measure the total factor productivity, they have not taken into account the CO2 aspect. So, but when you like to include the CO2 into the measurement of the productivity, so that is called as a green total factor productivity. Broadly, studies use the called as a Malquest Luxembourg index. So that can also be used for the analyzing the aggregate green total factor productivity. And when you are not accounting for the CO2 and when you're going to account for CO2, one kind of productivity difference here we found. Again, that also can able to highlight there. Yes, Santosh.
Yes.
Sir,
Dr.
you are
Sahu, you are muted.
Yeah, I mean, I'm really sorry to get in. Steve, can you please tell what is green TFP? I mean, can we take emission as an input matrix?
Yes, sir, because recently a lot of studies are discussing on that part aspect related to green TFP, because earlier studies they have simply used the labor, capital and other inputs while measuring the productivity. But while we're going to account for the CO2, so that really discuss about the green total factor productivity using this Luxembourg, this Malchus productivity index. We'll use that in the recent periods. Enjoy anything?
It started in 1980s actually, when it was all about the metrics is all about output. The metrics is all about the input and what is the input and output is there. It is by the FAIR and I guess 1997. It has become popular that what are they doing is they are penalizing the output. If you look into all the calculation and all those things, what they are doing is if there is GB in that, what they are trying to do is penalizing. We can also call it as a carbon productivity also, because it's like GB upon
Yes,
CO2. It
yes.
can
So
also be.
that is where I would probably agree more.
Yes,
I mean,
it can be a carbon productivity also, but what they are trying to do is that carbon productivity and then seeing what are the inputs that are being used in that and what is the carbon productivity and then getting the efficiency score out of that. So still it is being done by many of the authors and many good authors over the period of time that they are trying to penalize the output itself from the firm. That not only CO2, there are wide range of arrays. Like it has been suggested to us by you also that nitrous oxide. Like I would like to mention the CCEW report in 2019. They have done a comprehensive work on this carbon emissions of ASI data. They have calculated the other emissions also and total aggregate greenhouse gas emissions also. We are studying that report also. So it is that we have studied. This is just a start. We have gone for the carbon emissions. In future, we can definitely go for the other waste also, because it is not like all the firms are just going for the carbon emissions. There are other pollution also from those firms, which are yet not being accounted by those firms.
And thank you also again, CEW also got a lot of it because their
Also-
studies gives a detailed comprehensive record of different, not only CO2, but greenhouse gas, nitrogen, different kind of aspect as well. So there's a lot of discussion and how to analyze that. We get a detailed idea from their studies as well. Thank you, CEW, for that.
And next question is from Ms. Rupa Ranjari Stenare, MDI. How clean and technology increases TFP? Any technological advancement may lead to TFP. Since the major lack of this data is we cannot compare it with the country level statistics or country level metrics we are going to or index we are going to find out. So considering the data which is given to us, the only variable which could be find which we have found is that IT apparatus. People call it ICT also. IT apparatus is also there, and it has been popularized by many of the authors. Like Goldas are used in like ICT only, and there are studies who are using IT apparatus. So definitely, it is having a impact. Like you are using computers and you are using all those things, because when it is like that, how much expenses on the computer and other softwares, you are mechanizing your whatever way you are doing, you're mechanizing your production process. So that is the way in which it is going to have a positive impact on the TFP. And if we go into the other way of finding the TFP, like using frontier analysis, then we can definitely find that whether it is a technological change or whether it is an efficiency change. But by this growth accounting method, we cannot find that, we cannot separate those changes. By the frontier analysis, we are working on the frontier analysis of that also, that can definitely tell that whether there is a technological change was there or whether there is an efficiency change was there in the industry itself.
Any more comments that you like to mention? Otherwise, I'll do.
It's okay with me. Thank you. And there was a second question from my side, but that has also been addressed because I think the third discussant had already talked about it.
Any other comments that the authors wish to make on the chat box?
Sir, Ashwini Gupta has mentioned about what is the impact of automation and artificial intelligence on the manufacturing sector on the carbon emission trend. Again, sir, because as you know, there is a latest data is available on this particular aspect related to automation, machine learning. Again, from the larger, broader perspective, I think we may be able to get somewhere, but I have no idea regarding that particular aspect. I think Santosh sir can able to highlight that part regarding automation in the manufacturing sector.
Okay, so quickly, I would, so basically now the idea is open to look at not only CO2 emission, but scope 1, scope 2, scope 3 emissions. So most of this can come in scope 2, scope 3 emissions, depending on the structure of the industries and where they are using the AI and other activities. So this data is not readily available except 100 forms, registered forms in India. But again, getting the data is a little difficult on the scope 1, scope 2, scope 3 emissions. But again, the government has come up with certain standards now. For example, all of us know that there is something called BRSR reporting has come up. So once the BRSR reporting becomes standardized, then it would be easy to understand the automation and AI part and how it can be linked with emissions, whether the change can be done because of the implementation of those. Because the author themselves said that once adoption of technology, there is also a probability that the energy intensity goes up, the energy use goes up. But if there is a substitution of technology which will reduce the emissions, that has to be looked at. So once the data is available, yes, it is possible. But at this point in time, unless scope 1, scope 2, scope 3 emissions data is not there, it remains as an aggregate data for kind of, to analyze what happens at either unit level or factory level. Basically to come up with profiling of factories in terms of carbon emissions. I would put it in that way, because this is a field which is growing in last few years. Data has been very difficult for all researchers, including me. It's very difficult task because again, conversion factors varies depending on different locations and geographies. It's a good idea. Thank you very much for raising this. But yes, one can definitely look at it if the data becomes available.
Ma'am, regarding the other comments that have been mentioned, I think most of them we have already highlighted during the discussion. One thing is about whether there is an NCEP persist, because as the earlier studies discuss about the inverted U, but when you can find, if you look about the point of time, we try to measure the cube of that particular TAP, you can find there's an NCEP pattern broadly is existed inside of the inverted U that we broadly studied and analyzed in our study.
Any other responses that the authors would like to make? Otherwise,
So, ma'am, ICT is being asked about the ICT, that ICT, how ICT is, but thing we need to understand that ICT is not directly the index which being used by the other studies. Here, the ICT is taken as a proxy. We have taken a proxy from the data itself, because there is as so far I know, there is one block which gives the information that how many phones are using what type of that mobile phones or some related to that. It is not being available. The only thing available in the fixed capital, the C block, is that how much the firm is spending on the computer and other apparatuses. And following the approach of the earlier authors itself, from the Goldar's paper from 2017 also, 2019 also, we have taken it as a proxy. It is a challenge of the data itself. It is a challenge of the data itself. For ASI, we are doing it. So it is a challenge of the, for us, it's a data itself. We have been doing it for, like Mitra sir has done it for ICT and TFT, but he has used CMI data basically. So for them to compare those, making a index for from the other variables and comparing it with the CMI data, that is easier. But for the ASI, it was a challenge for us. That's why we have taken it from the earlier literature.
Yeah, I
I
understand.
also agree with that because, as you know, the last block of this ASI questionnaire gives a detailed information related to ICT, but most of the information is not available in the unit level data format except this block C. So if that could have been available, we could have used that, but this has taken again, as he has mentioned, as a proxy while estimating this particular ICT in our study.
Great. And just a quick comment on two of the comments in the chat box. First is about AI. Very recent, interesting data coming company level, not like data set that could be used for regression, but both Amazon and Google, the energy used from AI has shot through the roof. And very recent data, a couple of weeks back, that they are surprised themselves at how, because these are large language models. For training these models, you need a lot of data. So the efficiency in these models simply means if you are able to use less data for training the model and predict accurately. So that becomes a robust and efficient large language model. But right now we are very far from that. So it essentially means these are energy guzzlers, all the AIs and all. So their own net zero targets. It is being they are themselves saying that we won't be able to meet it only on the account of AI, because AI has grown so rapidly and the energy we have never foreseen the amount of energy used by AI. This is a new trend, so it is a very real important variable for all of us to think about as the use of AI starts growing across the larger economy. So it's a very interesting new variable that is entering in this whole discourse. So that's on AI. There is a second question on panchayats and if one can do assessments of net zero. This is essentially a kind of a carbon footprint assessment. The question, so carbon footprint you can do at the company level, you could do at the city level, you could do at a panchayat level, but the methods are kind of fairly straightforward. And we are also doing something with IUC and in the initial stages, which is about village level carbon footprinting assessment, something like that. So it could be very well done. The approaches are kind of very straightforward on that. Thank you.
Yeah. Thank you, sir. Actually, adding to that, actually, relating to this carbon footprint, recent one or two studies also discuss about the district level carbon footprints. If that is you want, I can also share that study with you. Thank you.
Yes, I'm Vineet. I'm working as an analyst at Forrester. My basic question is that point is that, that as far as the total factor productivity improves with the, carbon intensity, all that, is to be revisited simply because, there was an analysis by the Maruti and the Hyundai, recently that around a decade back, they used to use around 50 laborers for one car, producing one car. Now it has been reduced to, robots, and basically through robots, they are using less labor, but at the same time, they are still using a lot of energy, a lot of water. And these basically manufacturing units have basically been shifted towards very, very remote areas in the hinterlands, So basically they are for the infrastructure also, they are using a lot more of, what you call supply chains are basically getting a lot more complex, because they have to maneuver, a lot of these, technologies on AI, on components on, because the components of these automobiles also are basically getting very, very smart and very, very innovative and a lot more, lot more slim, etc. So how do you see that, seeing forward, on the front, basically, ICT basically looks very glamorous, it looks very good, that it will be able to, reduce the carbon emissions. But when you go deep inside, basically they are going to be using a lot of resources, a decade from now, on artificial intelligence, on energy and a lot more, minerals, etc. So which will put a lot of pressure, for example, as far as buildings are concerned, today are 30 floor 20 floor manufacturing outfits of Amazon in Hyderabad, basically, which use a lot of this water, from the groundwater. Previously groundwater can be pumped very easily. Now it is using a lot more of what you call drilling. Have to drill quite deep into it, with these hydraulics, etc. So how do you see that going forward, all that which will basically have impact on carbon emissions?
Okay. So thank you, sir, for your valuable comments. So to answer to the First aspect related to, as I clearly mentioned, this analysis is done at the aggregate level only. Again, across different sectors, we also bifurcated that different part in great detail. So which we are going for the subsequent study. As you rightly mentioned, one of the recent studies has discussed about, due to this increase in the temperature, there is a huge growth of these air conditioners nowadays. And mostly the metropolitan cities, you can find a simple building that you rightly mentioned. Let's a simple building. For 10 stories, you can find a multiple kind of air conditions. So demand is much more increasing, and that due to that CO2 aspect in different kind of, let's say, sectors is also differential kind of pattern of growth we also can find. Few sectors they may use someone like they use a kind of coal and some other aspects. In those particular sectors, where CO2 emission may be high. Others may those who are using, let's say, some kind of renewable aspect, the aspect may be low. So recent government of India also talking about lot related to this green transitions and this green jobs. So these aspects is much more important to discuss and debate.
Also, sir, I would like to highlight the mostly, if we have seen into the studies in the literature only, the mostly they're talking about the positive impact of ICT on TFP and other things, and negative impact, or it will reduce the carbon emission. But the point is that in literature, we have found that there are other aspects of ICT also. There is use effect also. They have now people are dividing the effect into other parts of it. That there is a consumption effect also. That those ICT need to be fueled. They need energy to be. So how it can be said that they will be having a negative impact on the carbon emissions? Like in our study also, we have rightly mentioned in our study in the paper itself that it is having a use effect also, because the sort of apparatus the phones will be using, they will be requiring the electricity or any other fuel to work for them. So that you are correctly pointing it out. Now we have to see into that which sort of industries are using maximum share of that and how their emissions are changing. That whether it is reducing that or increasing that, or it is having some impact on their productivity in comparison to emissions or not.
Hello everyone, I am Devanko. So I'm primarily from economics background and I work both in economic and energy modeling in TERI. So my questions are mainly from modeling perspective. So first question, you have estimated the CO2 emissions from manufacturing sector, right? So till 20, like, have you made any future projection about that?
Sorry, sir, could you please repeat it again?
Yeah, have you made any future projection about CO2 emission from the manufacturing sector?
No, sir, based on the availability data of 1920 only, we have tried to measure that. And as the latest data is also 2020. 122 also available. We have also measured that about that particular space CO2. But again, we are planning to measure the fuel. What is the, if the pattern of the CO2 is going in this way, what is the future trend is going to be? So we are in that process of estimating those parts.
Okay, so so regarding your idea about this emission trajectory, what do you think will be the multiplicative factor of emission in 2071? Like currently, for example, it is X amount. In 2071, it will be how much times? About your idea.
Again, once you're going to estimate that, again, you can able to come up with that. So once you're going to estimate, you can obviously love to share those results to you, sir.
Okay, and another question I have. One of the finding was as carbon emission increases, TFP decreases. Okay. So in the model, we put demand figures for both present and future. So we have estimated the demand figures and we put them as inputs in the model. So an implication of this finding, will it be reflected by reducing demand in the future? Like the amount which it was supposed to increase, will we reduce that in future? Because India is a developing country. So any compromise on fulfilling demand is like, it cannot come at the cost of like development. So I'm just trying to understand if from modeling perspective, how can we incorporate this in the model? Like the demand will reduce or because as far as I understood, another thing you said, increase in pollution control expenditure. So I can consider it as a duality. Like if we are increasing pollution control expenditure, there will be a linkage with increasing energy efficiency, right? So I can consider it in that way. But about this finding, how can we put inside the model? Just your perspective on that. So our model works basically on least cost optimization. So like this TFP thing, if we want to put it in the model, how can we put that?
Would you like to highlight or shall I explain?
So the voice was very less. I was trying to understand. He said that how can we put the TFP and CI, the relationship can be here. So the highlight of our study was to understand that whether the carbon emissions at increasing total factor productivity will decline, or the impact of total factor productivity. The demand cannot be a challenge, because the highlight of the study is that if there is carbon emissions, it can be a chance for the industries also. I may be incorrect, please correct me. That it can be a, we can say that it can be a chance for those industries to shift towards the better, better fuel. Like if they are using, because if we look into the amount of coal has been used by the industries over the period of time, and also the petroleum, it has a huge share that is going increasing, and only there is no decline in the coal being used by these industries.
Yeah.
So this can become like that if they are reducing, if they are shifting towards solar. Like in our study, we have not taken any emission factor for any, like if solar, we have implicitly taken that it is not emitting. So if they are moving towards those better and cleaner energy sources, then the emission can definitely decline, and that can be done by the productivity. If the firms are producing better and their output is increasing, the productivity is improvising, then definitely there is a push for them to shift towards better or another energy resources to fuel their processes. Like in our country also, we are developing also, but there is a shift that we want an energy transition for the country, and that transition could be changed by changing the structure of the energy, that what sort of fuel we are using. Considering these fuels, that coal, petroleum, and gas, these are highly emitting, and definitely they are going to have a negative impact.
Okay,
Yes, adding to that, as you know, a lot of studies also discuss about, and the government report also discuss about the kind of, let's say, coal and other kind of petroleum storage. It's maybe future it's going to be much more challenge. So what kind of transition also you like to make, and what are the government, what kind of policies they need to implement that challenge here for the government as well. Let's say for the green transitions, what kind of, let's say now there is a lot of manufacturing of the EV vehicles nowadays. And there's a lot of discussion is going on right there. These EV vehicles, whether it could be able to reduce the emission of the carbon intensity or not. So in that perspective, you can think about the demand may be increased for different products. It's going to be differently.
yes, I understand. So just last thing, the current policies globally do not reflect any like reducing of coal usage, because Germany is planning to start new coal plant. So Denmark is also planning to, like, they have previously said that they will decommission the existing coal plants, but there is no action on that part. So like I understand you are saying that there will be an energy transition, a fuel mix, shift in fuel mix, but the world is not taking policies that reflect that. So like modeling it tries to give a real perspective. We try to incorporate that in the model. So that's why I asked this question. I understand what you are trying to say. So thank you for that.